November 8th, 2025. The data streams have finally stabilised, but what they're showing has left astronomers staring at their screens in complete disbelief. For weeks, observatories around the globe tracked 3I Atlas as it approached its closest point to the Sun. Everyone expected a routine perihelion passage. Instead, what unfolded during those critical hours near our star has shattered every prediction model we had. This isn't your typical comet story. This is about an interstellar visitor that decided to rewrite the rules of physics right in front of our most sophisticated instruments. And the implications of what happened on October 29th might force us to reconsider everything we thought we knew about objects from beyond our solar system. If mysteries like this grab your attention the way they grab mine, make sure you hit that like button and subscribe so you don't miss any part of this investigation as it continues to unfold. Drop a comment letting me know where you're watching from and what time it is there, because this story spans observatories across every continent. Before we dive into the anomalies that have scientists scrambling for explanations, let me give you the setup. 3I Atlas was discovered as the third confirmed interstellar object to visit our solar system. Unlike the previous visitors, this one seemed to follow a predictable path toward the Sun. The trajectory calculations were solid. The thermal models looked standard. Every indication suggested we were watching a typical comet from another star system making its way through our neighbourhood. But as October 29th approached and 3I Atlas reached perihelion at 1.36 astronomical units from the Sun, something unprecedented happened. The object didn't just survive the intense solar radiation, it responded to it in ways that have left researchers questioning whether they witnessed a natural phenomenon or something far more extraordinary. The first sign that something was wrong came from the thermal readings. At that distance from the Sun, any normal comet should have reached temperatures around 280 Kelvin. The expected behaviour would involve massive outgassing, visible jets of vapour, and the typical brightening we associate with solar heating. 3I Atlas barely crossed 170 Kelvin. That's not just unusual, that's a direct violation of basic energy balance principles. Think about what this means. The object was receiving enormous amounts of solar radiation, yet somehow it was either reflecting most of that energy or managing it in ways our instruments couldn't detect. The thermal signature looked more like an engineered heat management system than a natural rock heating up under the Sun's glare. The brightness data told an equally puzzling story. Instead of the gradual brightening followed, by gradual dimming that characterises normal cometary behaviour, 3I Atlas exhibited something completely different. For weeks leading up to perihelion, it maintained an almost mathematically perfect light curve. No random fluctuations, no unpredictable jets, just steady, controlled illumination that seemed to ignore the chaos typically associated with solar heating. Then came the moment that changed everything. Within a 4-minute window during closest approach, multiple observatories recorded a sudden spike in brightness. This wasn't the slow thermal glow of sublimating ice. This was instantaneous, like someone had flipped a switch. The object's visual magnitude jumped dramatically, then stabilised again as if nothing had happened. The Solar and Heliospheric Observatory captured the event in real time. The Parker Solar Probe, positioned perfectly for the observation, detected electromagnetic disturbances that coincided exactly with the brightness surge. 3 separate ground-based telescopes confirmed the same timing. This wasn't instrument error. This was a coordinated event witnessed by independent systems. But here's where things get really strange. The moment of maximum brightness didn't correspond to maximum solar heating like it should have. The peak occurred exactly when 3I Atlas was at its closest point to the Sun, but the spectral signature showed no signs of outgassing, no water vapour, no carbon dioxide emissions. Nothing that would explain such a dramatic increase in luminosity. Instead, the spectrum looked like pure reflection, as if the object had suddenly become a mirror, bouncing sunlight back toward our instruments with incredible efficiency. The polarization measurements supported this interpretation, showing characteristics we typically associate with smooth metallic surfaces rather than rough cometary material. The acceleration data added another layer of mystery. During those same critical hours, 3I Atlas began exhibiting a non-gravitational acceleration away from the Sun. This kind of behaviour can happen naturally when comets outgas asymmetrically, creating a rocket effect. But the direction and magnitude of this acceleration didn't match any known outgassing patterns. The force was too clean, too linear, too precisely aligned with the radial vector from the Sun. It looked exactly like what you'd expect from photon pressure acting on a large, thin, highly reflective surface. In other words, it behaved like a solar sail. JPL's navigation team ran the numbers multiple times. The acceleration profile matched their models for light pressure propulsion almost perfectly. The problem is that natural objects don't spontaneously develop the geometric and material properties necessary for efficient solar sailing. You need specific engineering parameters that don't occur in nature. The European Space Agency's solar orbiter provided additional confirmation from a different vantage point. Their instruments detected what appeared to be a localized reduction in solar wind density along 3I Atlas's path. This kind of plasma deflection typically occurs around objects with their own magnetic fields, like planets or spacecraft with magnetospheres. For a small interstellar object to create a measurable cavity in the solar wind requires either ferromagnetic materials actively responding to the Sun's magnetic field or an internally generated magnetic envelope. Neither option fits standard models of natural cometry composition. The spectroscopic analysis revealed even more puzzling details. During the brightness surge, narrow emission peaks appeared at wavelengths that don't correspond to any known cometary molecules. The spacing between these peaks followed mathematical ratios rather than chemical quantum transitions. It was as if the light itself had been encoded with information. Independent teams from the Very Large Telescope, Keck Observatory and Subaru all detected the same spectral features. The consistency across different instruments and hemispheres ruled out local interference or calibration errors. Something about 3I Atlas was producing structured light patterns that no natural process should be able to create. The infrared data told its own strange story. Around the time of perihelion, instruments detected faint absorption bands corresponding to nickel carbonyl and other organometallic compounds. These substances are typically found in industrial processes, not in primitive solar system bodies. They require controlled chemical environments to form and maintain stability. Even more intriguing was the thermal regulation pattern. As 3I Atlas moved through varying solar radiation levels, its surface temperature responded almost instantly to changes in illumination. Natural materials have thermal inertia. They heat up and cool down gradually. But this object seemed to adjust its thermal properties in real time, maintaining an optimal temperature regardless of solar input. The dust-tail behavior defied every known principle of cometry physics. Instead of the expected stream of particles blown away from the Sun by radiation pressure, 3I Atlas developed what appeared to be an inverted tail. The dust particles seemed to be flowing toward the Sun rather than away from it. This reverse geometry is theoretically impossible under normal circumstances. Radiation pressure and solar wind always push lightweight particles in the anti-solar direction. The only way to reverse this flow would be through electromagnetic forces strong enough to overcome radiation pressure. That would require magnetic field strengths thousands of times greater than any natural comet has ever exhibited. The Parker Solar Probe's magnetometer readings confirmed the presence of localized magnetic disturbances in the region where 3I Atlas passed. The plasma wave signatures showed evidence of field line reconnection and particle acceleration, phenomena typically associated with active magnetic environments rather than passive rocky bodies. As the object moved away from perihelion, the anomalies continued. The non-gravitational acceleration persisted for hours after the initial surge, following a smooth temporal curve rather than the chaotic fluctuations typical of natural outgassing. The brightness remained elevated far longer than thermal physics would allow. Multiple space agencies tried to reconcile these observations with known cometry behavior. Every model failed. The thermal profiles didn't match ice sublimation. The acceleration vectors didn't align with gas-jet dynamics. The spectral features couldn't be explained by known mineralogy. The only simulations that successfully reproduced the observed behavior were those that treated 3I Atlas as an artificial structure. When researchers input parameters for a thin, highly reflective surface with variable electromagnetic properties, the virtual object behaved exactly like the real one. This created an uncomfortable situation for the scientific community. The data pointed toward conclusions that challenged fundamental assumptions about interstellar objects. Yet the alternative explanations all required physics we don't yet understand, or materials that shouldn't exist in nature. The timing of these events relative to solar activity added another dimension to the mystery. During 3I Atlas's perihelion passage, the Sun itself was experiencing one of its most active periods in months. Massive solar flares erupted from sunspot region AR3510, sending charged particles streaming across the inner solar system. The correlation between solar activity and the object's anomalous behavior was too precise to ignore. Every major deviation in 3I Atlas's properties coincided with peaks in electromagnetic radiation from the Sun. It was as if the object was responding to solar signals rather than simply enduring solar heating. As we piece together what happened during those extraordinary hours near the Sun, one fact becomes undeniable. 3I Atlas didn't behave like any natural object we've ever observed. Whether that means we've discovered new physics or encountered something artificial remains the central question driving ongoing investigations. The implications extend far beyond this single event. If interstellar space contains objects with properties we can't yet explain, our understanding of the galaxy itself may need fundamental revision. The possibility that intelligence once existed elsewhere, leaving traces that occasionally visit our solar system, transforms from science fiction into legitimate scientific inquiry. The data inconsistencies emerged as perhaps the most troubling aspect of the entire event. When NASA's Jet Propulsion Laboratory compared their readings with the European Space Agency's solar orbiter and ground-based observatories, something unprecedented happened. The numbers didn't match, not by small margins that could be attributed to calibration differences or measurement uncertainty, but by significant amounts that suggested each instrument was observing a fundamentally different phenomenon. JPL's tracking data indicated that 3I Atlas had accelerated away from the Sun in a clean, linear fashion consistent with radiation pressure. Their models showed a straightforward non-gravitational boost that could theoretically be explained by photon pressure acting on a reflective surface. The trajectory calculations were precise, the acceleration vector was radial, and the magnitude fell within expected parameters for a solar sail-type interaction. But the solar orbiter told a completely different story. ESA's instruments detected what appeared to be a temporary deceleration, as if 3I Atlas had actually slowed down during perihelion before resuming its outward motion. The magnetometer readings suggested the object had briefly resisted the solar wind, creating a localized disturbance in the plasma flow that lasted several hours. Meanwhile, ground-based telescopes from Chile to Hawaii recorded yet another version of events. Their astrometric measurements placed 3I Atlas almost exactly where Newtonian gravity predicted it should be, with no measurable deviation from a purely gravitational trajectory. According to these observations, no anomalous acceleration had occurred at all. 3 different observational approaches, 3 completely incompatible results. In normal circumstances, such discrepancies would be resolved through cross-calibration and error analysis. But when the teams attempted to reconcile their datasets, the inconsistencies only deepened. Each correction made the other measurements look more wrong, not less. The polarization measurements revealed an even stranger pattern. JPL's optical tracking showed positive polarization consistent with a bright reflective surface. But the solar orbiter, positioned at a different angle relative to the object, recorded negative polarization. The light was apparently aligned in opposite directions depending on the observer's perspective. This kind of directional polarization effect is theoretically impossible for natural materials. Light reflected from dust, ice, or rock should maintain consistent polarization characteristics regardless of viewing angle. The only known materials that can produce angle-dependent polarization changes are engineered surfaces designed for specific optical properties. The spectroscopic data added another layer of confusion. Different instruments detected completely different emission lines during the brightness surge. The Very Large Telescope recorded peaks at wavelengths associated with metallic compounds. Keck Observatory saw absorption features suggesting organic molecules. Subaru detected neither, instead showing a flat spectrum characteristic of pure reflection. It was as if 3I Atlas was presenting a different face to each observer, customizing its appearance based on the specific instrument and viewing geometry. The object seemed to possess multiple optical personalities, each revealed only under particular observational conditions. The thermal imaging created perhaps the most perplexing contradiction of all. Infrared telescopes detected emissions at wavelengths that indicated surface temperatures well below what solar heating should produce. Yet visible light measurements showed brightness levels that required much higher temperatures to generate. The object was simultaneously too cold and too hot, depending on which wavelength you observed. When researchers attempted to create unified models incorporating all available data, the simulations broke down completely. No single set of physical properties could account for the full range of observations. The object would need to be metallic and rocky and icy all at the same time, with surface temperatures that varied by hundreds of degrees across distances of meters. The radio astronomy data introduced yet another puzzle. Several observatories detected faint emissions in the megahertz range during and immediately after perihelion. The signals weren't strong enough to constitute definitive transmissions, but they showed structure and periodicity that natural plasma interactions typically don't produce. The Allen Telescope Array recorded bursts lasting exactly 1.7 seconds, separated by intervals of 19 hours. Japan's Yasuda Deep Space Center detected similar patterns but with slightly different timing. France's Nancy Observatory saw the same frequency range but with amplitude modulation that suggested the source was rotating or oscillating. These radio signatures correlated with the optical brightness variations in ways that defied explanation. Each time 3i Atlas pulsed in visible light, a corresponding radio burst appeared roughly 3 hours later. The delay was consistent across multiple observation cycles, as if the object was processing or retransmitting the optical energy in a different form. The magnetic field measurements from the Parker Solar Probe revealed localized disturbances that moved with 3i Atlas as it traveled through the inner heliosphere. These weren't random fluctuations in the solar wind, but structured patterns that suggested the object was actively modifying the electromagnetic environment around itself. The plasma density maps showed a cavity trailing behind 3i Atlas, a region where solar wind particles were being deflected or absorbed. This wake persisted for hours after the object had passed, gradually dissipating but maintaining its basic structure far longer than natural processes should allow. When scientists attempted to model these electromagnetic effects, they found that reproducing the observed patterns required assuming the object possessed its own magnetic field comparable in strength to a small planet. For a body estimated to be less than 200 meters across, such field strength would require either exotic, magnetic materials or active field generation. The trajectory analysis became even more complex when researchers extended their calculations beyond perihelion. As 3i Atlas moved away from the Sun, its path began deviating from all gravitational predictions, not dramatically but consistently, as if the object was making small course corrections to maintain a specific heading. The deviation wasn't random or chaotic like typical cometary motion influenced by outgassing jets. It followed smooth curves that suggested deliberate navigation rather than natural perturbation. The object appeared to be steering itself toward a specific region of interstellar space, avoiding the gravitational influences of the outer planets. When orbital analysts projected the trajectory backward to determine where 3i Atlas had originated, they discovered another anomaly. The object hadn't approached from random interstellar space as expected. Its incoming vector aligned almost perfectly with the solar apex, the direction our entire solar system moves through the galaxy. This alignment implied that 3i Atlas had been travelling parallel to our solar system's motion for an extended period before entering the Sun's gravitational influence. The probability of such precise alignment occurring by chance is extraordinarily small, suggesting either remarkable coincidence or deliberate targeting. The spectral evolution continued to puzzle researchers as 3i Atlas moved away from the Sun. Instead of returning to its pre-perihelion characteristics, the object maintained many of the anomalous features that had appeared during closest approach. The narrow emission lines persisted for days, the metallic absorption bands remained visible, and the overall reflectivity stayed elevated far longer than natural processes could sustain. Most troubling was the discovery of what appeared to be a fading plasma trail extending along 3i Atlas's outbound trajectory. This wake wasn't composed of dust or gas like typical cometary tails, but seemed to be made of ionized particles organized into filamentary structures that twisted and braided as they dispersed. The wake's geometry defied conventional plasma physics. Instead of expanding uniformly as it moved away from the Sun, the structure maintained coherence across distances of millions of kilometers. It was as if invisible magnetic field lines were holding the plasma in organized patterns, preventing the natural dissipation that should occur in the solar wind. Ground-based radio telescopes continued detecting faint signals from the wake region, long after 3I Atlas itself had faded from view. These emissions weren't coming from the object directly, but from the ionized trail it had left behind. The plasma was somehow maintaining electrical activity without any apparent energy source. The persistence of these anomalous features raised fundamental questions about what had actually occurred during perihelion. If 3I Atlas was simply a natural comet that had experienced unusual heating, all of these exotic properties should have dissipated quickly once it moved away from the sun's influence. Instead, many of the anomalies were intensifying rather than fading. The implications were becoming impossible to ignore. Every attempt to explain 3I Atlas's behavior through known physics required assumptions that violated other well-established principles. The object seemed to exist in a state of permanent contradiction, exhibiting properties that couldn't coexist in any natural material. As November progressed and 3I Atlas continued its journey toward the outer solar system, the astronomical community found itself grappling with questions that extended far beyond a single unusual object. The event had revealed gaps in our understanding of fundamental physics and raised possibilities that most scientists weren't prepared to seriously consider. The debate that emerged would split the research community along lines that hadn't existed before the perihelion passage. On one side were those who insisted that natural explanations must exist, even if we hadn't discovered them yet. On the other were researchers who began entertaining the possibility that 3I Atlas represented something entirely outside our current understanding of what interstellar objects could be. The data continued flowing in from observatories around the world, each new measurement adding complexity rather than clarity to an already bewildering situation. And as the implications of what had been observed began to sink in, one question overshadowed all others. If 3I Atlas wasn't natural, what did that mean for our understanding of intelligence in the universe? The answer to that question would come from an unexpected source. Dr. Avi Loeb, the Harvard astrophysicist who had previously suggested that Oumuamua might be artificial, had been quietly tracking 3I Atlas since its discovery. Months before the perihelion event, his team at the Galileo project had published a series of predictions that most of the astronomical community had dismissed as overly speculative. Loeb's models assumed that 3I Atlas might be a fragment of an artificial light sail, a thin, reflective structure designed to harness radiation pressure for propulsion. Based on this assumption, his team predicted that the object would exhibit three specific behaviors during its solar encounter: a non-gravitational acceleration aligned radially away from the sun, a sudden increase in brightness uncorrelated with thermal heating, and a temporary inversion of particle flow due to electromagnetic effects. Every single prediction had come true with remarkable precision. The accuracy of Loeb's forecasts sent shockwaves through research institutions worldwide. It wasn't just that he had been right about the general behavior. The specific timing, magnitude, and duration of each anomaly matched his calculations almost exactly. The probability of such precise predictions succeeding by chance was astronomically small. Within days of the perihelion event, Loeb's team released a detailed analysis comparing their light sail model to the observed data. The correlation was undeniable. When they simulated a thin, highly reflective surface roughly 50 meters across and less than a millimeter thick, the virtual object behaved exactly like 3I Atlas had during its solar passage. The implications were staggering. If Loeb's interpretation was correct, humanity had just witnessed the first confirmed detection of extraterrestrial technology. Not a signal from space, not a distant techno-signature, but actual physical hardware from another civilization passing through our solar system. The scientific community's response was swift and polarized. Establishment researchers pushed back hard against the artificial hypothesis, arguing that extraordinary claims required extraordinary evidence. They pointed out that natural explanations, however unlikely, should always be preferred over invoking alien intelligence. Critics noted that Loeb had a history of controversial interpretations, particularly regarding Oumuamua. They suggested that his predictions about 3I Atlas might have been lucky guesses rather than genuine insights. The fact that he had been preparing for such an event for years, they argued, meant he was predisposed to see artificial patterns in natural phenomena. But the data refused to cooperate with conventional explanations. Every attempt to model 3I Atlas as a natural object failed to reproduce the full range of observed behaviors. The thermal regulation, electromagnetic coupling, and structural coherence all pointed toward engineered systems rather than random cosmic debris. The international space agencies found themselves in an unprecedented situation. NASA, ESA, and other organizations had to balance scientific skepticism with the growing evidence that something extraordinary had occurred. Their public statements remained cautiously neutral, acknowledging the anomalies while avoiding speculation about their origin. Behind closed doors, however, emergency meetings were convening at the highest levels. Government officials were briefed on the possibility that an alien artifact had been detected. Defense departments began considering the implications of advanced technology passing through Earth's vicinity. The usual protocols for handling potential extraterrestrial contact simply didn't apply to an object that was already leaving the solar system. The media coverage intensified the debate rather than clarifying it. Science journalists struggled to present the story responsibly, balancing genuine scientific uncertainty with public fascination about possible alien visitors. Headlines ranged from cautiously skeptical to sensationally speculative, often misrepresenting the actual state of the evidence. Social media platforms exploded with discussion, conspiracy theories, and amateur analysis. Everyone with access to telescope data seemed to have an opinion about what 3i Atlas represented. The signal-to-noise ratio of useful information plummeted as speculation overwhelmed factual reporting. Meanwhile, the object itself continued its journey outward, steadily fading from view as it moved beyond the reach of most Earth-based instruments. Each passing day made follow-up observations more difficult, reducing the chances of gathering additional evidence that might resolve the mystery definitively. The radio emissions that had been detected during perihelion gradually weakened but didn't disappear entirely. Sensitive receivers continued picking up faint signals associated with 3i Atlas's trajectory for weeks after the visual sightings ended. The persistence of these transmissions suggested that whatever had been activated during the solar encounter remained partially active. Deep space tracking networks maintained their vigil, monitoring the object's position and velocity with increasing uncertainty as it receded into the outer solar system. The trajectory corrections that had been detected immediately after perihelion continued, confirming that 3i Atlas was not following a purely gravitational path. The course changes weren't random or chaotic, like those produced by cometary outgassing. They followed smooth, deliberate arcs that suggested active guidance rather than natural perturbation. The object appeared to be navigating toward a specific destination in interstellar space, though its ultimate target remained unknown. Attempts to communicate with 3i Atlas using radio telescopes and laser transmitters yielded no detectable response. If the object was indeed artificial, and potentially still functional, it showed no interest in acknowledging Earth's presence or attempting contact. Its behavior remained focused on whatever mission or program had brought it to our solar system. The lack of communication attempts didn't necessarily argue against the artificial hypothesis. An ancient probe or derelict spacecraft might lack the capability or programming to respond to signals from an unknown civilization. Alternatively, any intelligence sophisticated enough to construct interstellar vehicles might operate on timescales or according to priorities that made human contact irrelevant. The scientific analysis continued even as the object faded from direct observation. Research teams around the world pored over every scrap of data collected during the perihelion passage, looking for additional clues about 3i Atlas's nature and origin. Computer models grew increasingly sophisticated as more processing power was dedicated to understanding the anomalies. Spectroscopic analysis revealed subtle features that hadn't been noticed during the initial observations. The narrow emission lines that had appeared during the brightness surge showed fine structure, consistent with highly organized molecular arrangements. The spacing and intensity ratio suggested crystalline lattices or engineered materials rather than random chemical compositions. The polarization data yielded additional insights when subjected to detailed mathematical analysis. The directional effects that had been detected weren't just unusual for natural materials, they were diagnostic of specific types of engineered surfaces. Metamaterials and photonic crystals could produce exactly the kind of angle-dependent optical properties that 3i Atlas had exhibited. Thermal modelling of the perihelion event required increasingly exotic assumptions to match the observed temperature profiles. The object's ability to regulate its surface temperature suggested either advanced materials science or active thermal management systems. Natural substances simply couldn't account for the rapid response times and temperature stability that had been recorded. The magnetic field measurements from the Parker Solar Probe underwent extensive reanalysis as researchers tried to understand the electromagnetic phenomena that had accompanied 3I Atlas's passage. The localized disturbances in the solar wind weren't just anomalous, they were structured in ways that implied deliberate field generation rather than passive interaction. Plasma physicists developed increasingly sophisticated models to explain how a small object could create such large-scale electromagnetic effects. Their calculations consistently pointed toward active field generation, possibly through superconducting loops or plasma confinement systems. Such technologies were theoretically possible, but far beyond current human capabilities. The trajectory analysis became more complex as additional data points accumulated. The object's path through the solar system showed subtle but persistent deviations from purely gravitational motion. These course corrections weren't random, they appeared to be steering 3I Atlas toward a specific region of interstellar space while avoiding close encounters with the outer planets. When astronomers projected the trajectory backward to determine the object's origin, they discovered another puzzling feature. 3I Atlas hadn't approached from the direction of any known stellar system. Its path traced back to apparently empty space, suggesting it had been travelling through the interstellar medium for an extremely long time. The duration of such a journey raised questions about the object's age and purpose. If 3I Atlas was indeed artificial, it might represent technology from a civilization that had vanished millions or billions of years ago. The implications of such ancient intelligence were profound, suggesting that technological civilizations might be far more common in galactic history than previously assumed. Alternative theories continued to emerge as researchers grappled with the unprecedented observations. Some scientists proposed that 3I Atlas might represent a new class of natural object formed through exotic astrophysical processes. Interactions between stellar winds, magnetic fields, and interstellar dust might theoretically create structures with some of the observed properties. Others suggested that the object could be a fragment of a disrupted planetary system, perhaps torn apart by tidal forces during a close encounter with a massive star. Such catastrophic events might produce debris with unusual material properties and coherent structures that could persist during interstellar travel. The most conservative researchers maintained that natural explanations must exist, even if they required physics we didn't yet understand. They argued that invoking artificial origins was premature and potentially damaging to the credibility of astronomical research. The scientific method demanded exhausting all natural possibilities before considering extraordinary alternatives. But as the analysis continued and the anomalies accumulated, even the most skeptical scientists found their certainty wavering. The sheer number of unusual properties exhibited by 3I Atlas was beginning to strain the limits of coincidence. At some point, the accumulation of anomalies itself became evidence of something beyond normal astrophysical processes. The debate over 3I Atlas's nature would continue long after the object had vanished from observable space. The data it left behind would be analysed and reanalyzed for years to come, with each new technique revealing additional layers of mystery. But regardless of the ultimate conclusion about its origin, 3I Atlas had already accomplished something remarkable. It had forced humanity to confront the possibility that we might not be alone in the universe. As 3I Atlas faded into the cosmic background, its legacy lived on in the questions it had raised and the paradigms it had challenged. The solar system suddenly felt less empty, the galaxy less lifeless. Whether natural or artificial, 3I Atlas had demonstrated that interstellar space contained wonders we were only beginning to understand. The hunt for similar objects began immediately, with astronomers worldwide scanning the skies for other visitors that might exhibit comparable anomalies. If 3I Atlas represented a new class of interstellar object, there might be others waiting to be discovered. And if it was indeed artificial, it might not be alone in the vast expanse between the stars. The implications extended far beyond astronomy into philosophy, theology, and the fundamental question of humanity's place in the cosmos. If intelligence could create artifacts capable of surviving interstellar journeys lasting millions of years, what did that say about the persistence of civilization? What did it mean for our own future as a spacefaring species? These questions would drive research and speculation for decades to come. But for now, as November 2025 drew to a close, one fact remained clear. 3I Atlas had given humanity its first genuine mystery of the space age, a puzzle that would challenge our understanding of both physics and possibility for generations to come. Generations to come. The silence that followed for all I, Atlas's departure, carried more weight than any of the noise that had preceded it. By December 2025, the object had moved beyond the reliable range of most Earth-based tracking systems, leaving behind only fading radio whispers and a scientific community fundamentally changed by what they had witnessed. But the story was far from over. In fact, the most disturbing revelations were just beginning to emerge from the data archives. Deep in the computer servers of observatories around the world, automated analysis programs continued their relentless work. Machine learning algorithms designed to spot patterns in astronomical data had been quietly processing the 3I Atlas observations, cross-referencing them against decades of archived measurements from previous missions and surveys. What they found would shake the foundations of our understanding even further. The breakthrough came from an unexpected source. Dr. Sarah Chen, a data scientist at the Jet Propulsion Laboratory, had been training neural networks to identify unusual objects in historical survey data. Her programs were designed to spot asteroids and comets that human observers might have missed, buried in the overwhelming flood of images collected by automated sky surveys over the past 20 years. When Chen fed her algorithms the spectroscopic signatures of 3I Atlas, something remarkable happened. The programs immediately flagged 17 separate observations from various sky surveys dating back to 2019. Objects that had been catalogued as distant stars or background noise suddenly revealed themselves as potential matches for 3I Atlas's unique optical characteristics. The implications were staggering. If these detections were genuine, they suggested that 3I Atlas had been present in the outer solar system for years before its official discovery. More troubling still, the archived observations showed the same anomalous properties that had baffled researchers during the perihelion passage. The narrow emission lines, the unusual polarization signatures, the temperature regulation that defied conventional physics. Chen's team worked around the clock to verify their findings. They pulled the original data from storage systems that hadn't been accessed in years, running multiple verification algorithms to ensure they weren't seeing false positives. The results held up under scrutiny. 3I Atlas, or objects virtually identical to it, had been quietly moving through our solar system long before anyone realized they were there. The discovery prompted an immediate review of observation protocols at major observatories. How many other unusual objects had been dismissed as instrumental artifacts or cataloging errors? How many genuine anomalies had been hiding in plain sight within the vast databases of astronomical measurements? The European Space Agency launched their own retrospective analysis, focusing on data from missions that had been operating during the timeframe of Chen's detections. The Gaia spacecraft, which had been precisely measuring stellar positions and motions since 2013, revealed additional surprises when its archives were searched for objects matching 3I Atlas's characteristics. 3 separate detections emerged from the Gaia data, each showing objects with the same inexplicable brightness, stability, and spectral features that had made 3I Atlas so puzzling. The positions and timing suggested these might represent multiple objects, rather than repeated observations of the same visitor. The possibility that 3I Atlas was not unique, but part of a larger population of similar artifacts, sent shockwaves through the astronomical community. NASA convened emergency meetings to discuss the implications of multiple anomalous objects potentially present in the solar system. The detection protocols that had served astronomy well for decades suddenly seemed inadequate for identifying visitors that didn't behave according to conventional physics. New search algorithms were urgently developed, designed specifically to spot objects exhibiting the electromagnetic and thermal anomalies associated with 3I Atlas. The radio astronomy community made their own disturbing contribution to the growing mystery. When researchers at the Very Large Array began searching their archives for signals associated with the suspected 3I Atlas detections, they found something that challenged their understanding of interstellar communication itself. Faint radio emissions had been detected at multiple frequencies during several of the historical observation windows. The signals were too weak and too brief to have triggered automatic detection systems at the time, but they were clearly present in the archived data. More significantly, the emissions showed the same structured patterns and precise timing that had been observed during the perihelion event. The signals weren't random noise or natural plasma phenomena. They displayed characteristics consistent with engineered transmissions, though their purpose remained completely unknown. Some researchers speculated that the emissions might represent communication between multiple objects, a kind of interstellar network coordinating activities across vast distances. Dr. Jill Tarter, the renowned SETI researcher, was brought in to analyse the radio signatures. Her assessment was cautious but profound. The signals exhibited properties she had never encountered in decades of searching for extraterrestrial intelligence. They were clearly artificial in origin, yet they followed protocols completely unlike anything human technology had ever produced. The timing correlations between radio emissions and optical anomalies suggested a level of coordination that went far beyond coincidence. Whatever 3I, Atlas represented, it appeared to be part of a larger system that had been operating within our solar system for an extended period without detection. Ground-based telescopes began implementing new observation protocols specifically designed to catch similar objects. Instead of focusing on traditional cometary signatures like dust tails and gas emissions, they started looking for the electromagnetic and thermal anomalies that characterized 3I Atlas. The results were immediate and unsettling. Within weeks of implementing the new search criteria, observatories around the world began detecting objects that had previously been invisible to conventional surveys. Small, dark bodies moving through the outer solar system with the same regulatory temperature control and structured electromagnetic emissions that had made 3I Atlas so remarkable. The Catalina Sky Survey identified 3 potential candidates in their first month of targeted searching. The Linear project found 2 more. Each detection revealed objects with properties that violated conventional understanding of natural solar system bodies. They were too stable, too regulated, too obviously engineered to represent random cosmic debris. The discovery rate was accelerating. By January 2026, more than a dozen objects exhibiting 3I Atlas-like characteristics had been identified throughout the solar system. They ranged in size from a few meters to several hundred meters across, but they all shared the same fundamental anomalies that had made the original object so puzzling. Dr. Loeb's team at the Galileo project had been vindicated in their predictions, but the validation brought no satisfaction. The implications of multiple artificial objects operating within our solar system were far more disturbing than anyone had anticipated. These weren't random visitors or ancient derelicts. They appeared to represent an active presence, a technological infrastructure of unknown origin and purpose. The objects showed evidence of coordination that suggested they were components of a larger system. Their orbital mechanics were too precise, their timing too synchronized to represent independent artifacts. Radio telescopes detected communication signals passing between various objects, weak transmissions that followed protocols completely outside human understanding. Government agencies that had initially dismissed the 3I Atlas anomaly as an interesting but isolated scientific curiosity suddenly found themselves grappling with the possibility of an active extraterrestrial presence in Earth's immediate vicinity. Defense departments began classified assessments of the potential threat represented by advanced technology operating undetected within the solar system. The objects didn't appear hostile. They showed no interest in Earth or human activities, focusing instead on trajectories that kept them in the outer solar system, away from planetary interference. But their very existence raised fundamental questions about humanity's security and sovereignty in our own cosmic neighborhood. International space law, which had been developed to govern human activities in space, suddenly seemed woefully inadequate to address the presence of non-human technology. Who had jurisdiction over objects that predated human spaceflight by potentially millions of years? What rights did humanity have to investigate or interact with artifacts from other civilizations? The scientific community found itself divided between those who wanted to attempt communication with the objects and those who preferred passive observation until their purpose could be better understood. The risks of initiating contact were completely unknown. Advanced civilizations capable of deploying technology across interstellar distances might not appreciate interference from primitive species like humanity. Yet the opportunity to learn from genuinely alien technology was unprecedented in human history. The objects represented a chance to advance human understanding of physics, engineering, and the possibilities of technological civilization by centuries or millennia. The scientific potential was almost beyond calculation. efforts to decode the radio transmissions between objects consumed enormous computational resources as researchers tried to identify patterns or protocols in the alien communications. The signals were clearly structured and purposeful, but they followed mathematical principles that didn't correspond to human communication theory. Some researchers suggested that the transmissions might not be communications at all, but rather coordination signals for distributed sensing or computational networks. The objects might represent components of a vast information-gathering system, monitoring conditions throughout the solar system for purposes that remained completely opaque to human observers. The possibility that Earth itself was under observation by this network was both thrilling and terrifying. If the objects were indeed sensors or probes deployed by an advanced civilization, they might have been collecting data about human activities for years or decades without anyone realizing it. The implications for privacy, security, and human autonomy were staggering. Every radio transmission, every space mission, every aspect of human technological development might have been monitored and analyzed by intelligence far beyond human comprehension. The very foundations of human independence in the cosmos suddenly seemed questionable. Yet the objects showed no signs of interference with human activities. Satellites continued functioning normally. Space missions proceeded without disruption. Whatever the purpose of the monitoring network, it appeared to operate according to principles that didn't involve direct intervention in human affairs. The passive nature of the observation system suggested either benevolent intentions or complete indifference to human civilization. Both possibilities carried their own disturbing implications about humanity's significance in the broader context of galactic intelligence. As 2026 progressed, the catalogue of detected objects continued growing. Each new identification revealed additional layers of complexity in what was clearly a sophisticated technological infrastructure. The objects operated according to principles that human science was only beginning to glimpse, using energy sources and propulsion methods that remained completely mysterious. The network appeared to have been in place for an extended period, possibly predating human civilization entirely. If so, it represented evidence that advanced intelligence had been active in our solar system long before humans developed the capability to detect it. The implications for human uniqueness and cosmic significance were profound and unsettling. The discovery also raised questions about the prevalence of such networks throughout the galaxy. If one star system contained evidence of advanced technological presence, how many others might harbour similar infrastructure? The universe suddenly seemed far more crowded and far less empty than humanity had ever imagined. Radio astronomers began searching for similar signals from other star systems, looking for evidence that the network extending through our solar system might be part of an even larger galactic infrastructure. The preliminary results suggested that structured transmissions consistent with technological coordination might be present in multiple nearby systems. The possibility of a galaxy-spanning network of artificial objects monitoring stellar systems throughout the Milky Way transformed humanity's understanding of our place in the cosmic order. We were no longer alone, but we might also be far less significant than we had ever suspected. The objects continued their silent operations, following trajectories and protocols that served purposes beyond human comprehension. They represented questions that would reshape every field of human knowledge, from physics and engineering to philosophy and theology. But as researchers struggled to understand the implications of their discoveries, 3i Atlas itself had already moved beyond the reach of human observation. Somewhere in the darkness between stars, it continued whatever mission had brought it to our solar system. Its brief encounter with our sun had revealed its presence, but its true purpose remained as mysterious as the civilization that had created it. The legacy of that December morning when Chen's algorithms first identified the hidden patterns in archived data would echo through human civilization for generations to come. We had discovered that we were not alone, but we had also discovered that we might never understand what that truly meant. The objects in the network showed no signs of aging or degradation, despite what appeared to be extreme antiquity. Their technology operated according to principles that seemed to transcend the limitations that constrained human engineering. They represented a level of technological sophistication that human civilization might not achieve for millennia, if ever. Yet they remained tantalizingly present, continuing their observations and communications just beyond the edge of human understanding. They were proof that intelligence could create artifacts capable of surviving across cosmic timescales, but they offered no insight into the motivations or ultimate fate of their creators. As humanity began to adjust to the reality of sharing the solar system with advanced alien technology, one fact became increasingly clear. The discovery of 3I Atlas had been just the beginning of a much larger story. A story that would challenge every assumption about intelligence, technology, and humanity's role in a universe that was far stranger and more populated than anyone had ever dared imagine. The objects continued their silent vigil, watching and waiting for purposes that might never be revealed to the species that had finally learned to see them. They were monuments to intelligence that had transcended the limitations of biological existence, yet they remained as enigmatic as the darkness from which they had emerged. The months that followed would prove that 3I Atlas had left behind more than just questions. It had fundamentally altered how we observe the cosmos itself. By early 2026, observatories worldwide were implementing detection protocols that would have seemed like science fiction just years before. Instead of searching for the familiar signatures of rocks and ice, astronomers were now hunting for objects that managed heat like spacecraft and communicated like machines. The transformation in astronomical practice happened faster than anyone anticipated. The Vera Rubin Observatory, which had just begun its legacy survey of space and time, quickly adapted its algorithms to flag objects exhibiting the thermal regulation patterns that had made 3I Atlas so distinctive. Within the first month of operation, they identified 7 candidates that showed similar electromagnetic anomalies. Each new detection followed the same disturbing pattern. Objects that appeared ordinary in traditional surveys revealed extraordinary properties under closer examination. They maintained stable temperatures despite varying solar radiation. They exhibited structured radio emissions that suggested active communication systems. Most troubling of all, they seemed to coordinate their movements in ways that implied deliberate planning rather than random orbital mechanics. Dr. Michelle Bannister at the University of Canterbury led one of the first systematic studies of these newly detected objects. Her team developed what became known as the Artificial Object Classification System, a framework for distinguishing between natural solar system bodies and potential technological artifacts. The criteria were based directly on the anomalies that had characterized 3I Atlas during its solar encounter. Temperature regulation became the primary diagnostic tool. Natural objects heat up and cool down predictably based on their distance from the Sun and their material properties. The new class of objects maintained thermal equilibrium in ways that violated basic physics unless they possessed active heat management systems. This single characteristic proved more reliable than any other method for identifying artificial visitors. The European Southern Observatory contributed their own breakthrough when they began analysing the polarization signatures of suspected artificial objects. The directional light properties that had confused researchers during 3I Atlas's perihelion passage turned out to be diagnostic of engineered surfaces. Natural materials simply couldn't produce the angle-dependent optical effects that these objects routinely exhibited. Radio astronomy provided the final piece of the identification puzzle. The structured emissions detected during 3I Atlas's solar encounter weren't unique to that event. Similar signals appeared whenever multiple suspected artificial objects came within communication range of each other. The transmissions followed protocols that were clearly technological in origin, though their content remained completely opaque to human analysis. By mid-2026, the catalogue of identified artificial objects had grown to include more than 30 separate entities distributed throughout the solar system. They ranged in size from small probes barely 10 meters across to massive structures several kilometers in diameter. All shared the fundamental characteristics that had made 3I Atlas so remarkable: precise thermal control, electromagnetic communication capabilities, and movement patterns that suggested active guidance systems. The larger objects proved especially intriguing to researchers. Deep space telescopes revealed structures that appeared to be constructed rather than naturally formed. Geometric patterns, regular surface features, and symmetric shapes that had no analogue in natural asteroid or comet populations. These weren't just unusual rocks, they were clearly artificial constructions designed for purposes that remained completely mysterious. The discovery of manufactured structures operating within our solar system triggered emergency sessions at space agencies around the world. NASA convened a special committee to assess the implications of advanced alien technology sharing Earth's cosmic neighborhood. The European Space Agency launched similar investigations, as did the space programs of China, Russia, and India. The initial reaction was cautious, to the point of paralysis. No one wanted to be responsible for initiating first contact with a civilization potentially millions of years more advanced than humanity. The objects showed no hostile intent, but they also demonstrated capabilities that rendered human space technology obsolete by comparison. Any interaction carried incalculable risks, yet the scientific opportunity was equally unprecedented. These objects represented the first chance in human history to study genuinely alien engineering. The technological insights that could be gained from understanding their propulsion systems, communication methods, and construction techniques might advance human civilization by millennia. Dr. Loeb's team at the Galileo project found themselves at the center of the emerging research effort. Their successful prediction of 3I Atlas's behavior had established them as the leading experts on artificial interstellar objects. Funding poured in from government agencies and private organizations eager to understand the implications of the discoveries. The Galileo project's analysis revealed patterns in the artificial object network that suggested a level of organization far beyond what anyone had initially suspected. The objects weren't randomly distributed throughout the solar system. They occupied specific orbital positions that maximized their collective observational coverage while minimizing interference with each other. The positioning was so precise that it appeared to represent a designed surveillance network. Every region of the inner solar system fell within the observation range of at least two objects, ensuring redundant coverage and continuous monitoring capability. The implications for human privacy and autonomy were staggering. Government intelligence agencies that had initially dismissed the artificial object hypothesis as academic speculation suddenly found themselves grappling with the reality of advanced alien surveillance systems operating undetected for potentially decades. The objects had been watching human space activities, monitoring radio communications, and possibly analyzing every aspect of technological development on Earth. The realization that humanity had been under observation without consent or knowledge triggered intense debate about appropriate responses. Some officials advocated for attempts to disable or destroy the monitoring network. Others argued for diplomatic contact to establish communication with whatever intelligence controlled the objects. The military implications were equally complex. The artificial objects demonstrated propulsion and maneuvering capabilities far beyond anything in human arsenals. They appeared to generate their own power sources and maintain operational status across timescales that dwarfed human technological life cycles. Any conflict with their creators would be hopeless from the outset. Yet the objects showed no signs of aggression or interference with human activities. Satellites continued functioning normally. Space missions proceeded without disruption. The monitoring network appeared to operate according to principles of observation without intervention, suggesting either benevolent intentions or complete indifference to human concerns. The passive nature of the passive, the surveillance actually made the situation more unsettling rather than less. If the objects were actively monitoring human activities, but choosing not to interfere, it implied that humanity was being studied like laboratory specimens or zoo animals. The implications for human dignity and self-determination were profound. International law proved completely inadequate to address the situation. The Outer Space Treaty and other agreements governing space activities had been written with human actors in mind. They contained no provisions for dealing with alien technology that predated human spaceflight by potentially millions of years. Legal scholars began developing new frameworks for interacting with non-human intelligence in space, but the effort was complicated by the complete absence of communication from the object's controllers. How do you negotiate with entities that show no interest in acknowledging your existence? The scientific community remained divided between those who wanted to attempt active communication with the network and those who preferred continued passive observation. The risks of initiating contact were completely unknown, but so were the potential benefits of establishing dialogue with advanced alien intelligence. Radio telescopes began broadcasting carefully crafted messages toward the artificial objects, using mathematical concepts and physical constants as universal languages. The transmissions were designed to demonstrate human intelligence while avoiding any content that might be interpreted as threatening. The response was silence. The objects continued their operations without any acknowledgement of human attempts at communication. Their radio emissions maintained the same structured patterns they had always used, apparently for coordination between network components rather than external communication. Some researchers interpreted the lack of response as evidence that the objects were automated systems rather than actively controlled by living intelligence. Ancient probes programmed with specific missions might not have the capability or authorization to respond to contact attempts from unknown species. Others suggested that the controlling intelligence might operate on timescales so different from human experience that responses could take years or decades to formulate. Civilizations capable of deploying technology across interstellar distances might think in terms of millennia rather than moments. The possibility that humanity was dealing with post-biological intelligence also emerged as a serious consideration. The objects appeared to be constructed from materials and technologies that suggested capabilities far beyond what biological entities could develop or maintain. They might represent the artifacts of civilizations that had transcended their organic origins entirely. Archaeological analysis of the object's construction revealed evidence of extreme antiquity combined with ongoing functionality. The materials showed no signs of degradation despite apparent ages measured in millions or billions of years. The technology operated according to principles that seemed to transcend the limitations of entropy and wear that constrained all human engineering. The objects represented proof that intelligence could create artifacts capable of surviving across cosmic timescales while maintaining operational capability. They were monuments to technological achievement that human civilization could barely comprehend, let alone reproduce. Yet they remained tantalizingly present, continuing their silent observations just beyond the reach of human understanding. They offered no insight into their creators' motivations, ultimate fate, or intentions regarding humanity. They simply continued their ancient vigil, watching and waiting for purposes that might never be revealed. The psychological impact on human civilization was as significant as the technological implications. The discovery that advanced alien intelligence had been monitoring Earth for an unknown period forced a fundamental reassessment of humanity's place in the cosmic order. We were no longer alone, but we were also no longer in control of our own cosmic neighborhood. Religious leaders grappled with theological implications of alien intelligence that appeared to operate according to principles completely outside human moral and ethical frameworks. The objects showed neither malevolence nor benevolence, simply indifference to human concerns that was perhaps more unsettling than either extreme. Philosophers debated the implications for human free will and autonomy in a universe where advanced intelligence could monitor every aspect of terrestrial civilization. Did privacy have any meaning when dealing with technologies capable of observing across interstellar distances? The objects continued their operations regardless of human concerns or interpretations. They represented questions that would reshape every field of human knowledge while remaining as enigmatic as the darkness from which they had emerged. Educational institutions began developing new curricula to help students understand a universe populated by intelligence far more advanced than humanity. The discovery had transformed abstract possibilities into concrete realities that would influence human development for generations to come. Scientific research priorities shifted dramatically as funding flowed toward projects aimed at understanding alien technology. Traditional astronomy found itself competing with entirely new fields focused on technoarchaeology and xenotechnology analysis. The objects had given humanity its first glimpse of truly advanced civilization, but they had done so on their own terms according to their own incomprehensible agenda. They were proof that intelligence could transcend biological limitations and create artifacts that persisted across cosmic time, yet they offered no guidance for how humanity might follow similar paths. As 2026 progressed toward its end, the Artificial Object Network continued its silent operations. New detections added to the catalogue monthly, as improved observation techniques revealed additional components of what was clearly a vast technological infrastructure. The network appeared to extend beyond the solar system itself, with radio telescopes detecting similar structured emissions from nearby star systems. The possibility of a galaxy-spanning surveillance network monitoring stellar systems throughout the Milky Way suggested that advanced intelligence was far more prevalent and organized than anyone had previously imagined. Yet for all their advanced capabilities, the objects remained fundamentally alien and incomprehensible. They represented intelligence that had evolved along paths completely different from human development, according to priorities and motivations that might never be accessible to biological minds. The legacy of 3i Atlas's discovery continued expanding as its implications rippled through every aspect of human civilization. The object that had briefly flared near our sun had revealed a universe far more complex and populated than humanity had ever suspected. It had given us questions that would drive research and speculation for centuries, while providing no easy answers about our role in a cosmos dominated by intelligence we could barely recognize, let alone understand. The objects waited in the darkness, patient and eternal, carrying out missions assigned by minds that had transcended the limitations of flesh and mortality. They were witnesses to the rise and fall of countless civilizations, yet they remained as silent and enigmatic as the void between the stars. Stars. By March 2026, the silence had become more unsettling than any signal ever could. The artificial object network that had revealed itself following 3i Atlas's solar encounter continued its operations with mechanical precision, but the implications of their presence were reshaping human civilization in ways no one had anticipated. What started as the discovery of a single unusual interstellar visitor had evolved into the recognition that our solar system harbored an entire infrastructure of alien technology. The transformation in how we observed space was complete. Every major observatory on Earth had been retrofitted with detection systems specifically designed to identify objects that exhibited the thermal regulation and electromagnetic signatures characteristic of artificial constructs. The old methods of astronomy, searching for rocks and ice reflecting sunlight, seemed quaint in comparison to hunting for machines that actively managed their energy and communicated across vast distances. Dr. Elena Vasquez at the Atacama Large Millimeter Array had become one of the leading experts in what researchers now call techno-archaeology. Her team had developed sophisticated algorithms capable of distinguishing between natural, radio emissions and the structured communications that flowed constantly between artificial objects throughout the solar system. The signals followed mathematical patterns that suggested information exchange, though the content remained completely opaque to human analysis. The radio chatter between objects had intensified significantly since 3i Atlas's perihelion passage. What had once been occasional brief transmissions had evolved into continuous streams of data flowing along carefully maintained communication networks. The bandwidth utilization was enormous, suggesting that vast amounts of information were being processed and shared across the entire system. Signal analysis revealed that the network operated according to protocols that prioritized efficiency over redundancy. Unlike human communication systems that built in error correction and multiple pathways for critical data, the artificial network appeared to operate with perfect reliability. Messages were transmitted once and never repeated, suggesting either flawless transmission systems or error rates so low they were undetectable. The precision of the communication network extended to its timing. Messages arrived at their destinations exactly when expected based on the speed of light and the positions of transmitting and receiving objects. There was no delay for processing, no pause for acknowledgement, just seamless information flow that suggested automated systems operating according to predetermined protocols. Dr. Vasquez's team had identified over 200 distinct communication nodes within the solar system by early 2026. The objects weren't randomly distributed but occupied specific orbital positions that optimized network coverage while maintaining stable communication links. The positioning was so precise, it appeared to have been designed by engineers who understood orbital mechanics better than humanity's best experts. The network's architecture revealed itself through months of careful observation and signal tracking. Primary nodes, the largest artificial objects, served as central hubs that received and redistributed information from dozens of smaller probes. Secondary nodes acted as relay stations, extending communication range to objects operating in the outer solar system where direct transmission to primary hubs would be unreliable. The system showed remarkable adaptability when individual nodes failed or moved out of position. Backup communication pathways activated automatically, rerouting data through alternate channels without any apparent loss of functionality. The redundancy was built into the network's fundamental architecture rather than added as an afterthought, suggesting design principles far more sophisticated than human engineering had achieved. Attempts to decode the information content of the transmissions had consumed enormous computational resources without yielding meaningful results. The signals were clearly structured and purposeful, but they followed mathematical principles that didn't correspond to any known information theory. The data appeared to be compressed using algorithms that achieved ratios impossible with human technology. Some researchers suggested that the transmissions might not contain discrete information in the way humans understood it, but rather represented continuous streams of sensor data and system status updates. The artificial objects might be components of a vast distributed sensing network, constantly sharing observations about conditions throughout the solar system. The possibility that Earth itself was a primary focus of this monitoring system was supported by traffic analysis of the communication network. Objects positioned for optimal observation of terrestrial activities generated significantly more transmission traffic than those focused on other regions of the solar system. Humanity's home planet was clearly of special interest to whatever intelligence controlled the network. Ground-based telescopes had identified the largest artificial construct in late 2025, but its true scale only became apparent through months of careful observation. The object, designated AO1 by researchers, measured nearly 8 kilometers in length and appeared to be constructed from materials that absorbed certain wavelengths of light, while reflecting others with perfect efficiency. AO1 occupied a stable orbit in the asteroid belt, positioned to maintain continuous observation coverage of the inner solar system. Its surface revealed geometric patterns and regular structures that were clearly artificial in origin. Spectroscopic analysis showed material compositions that had no analogue in natural solar system bodies, suggesting construction techniques that human metallurgy couldn't reproduce. The massive construct served as the primary hub for the communication network, receiving and processing delta streams from hundreds of smaller objects throughout the solar system. The information throughput was staggering, equivalent to humanity's entire global internet traffic flowing through a single node every few minutes. Dr. James Harrison at the Cambridge Institute had spent months analysing the structural features visible on AO1's surface. The geometric patterns weren't decorative, but appeared to serve functional purposes related to the object's operations. Antenna arrays, sensor clusters, and what appeared to be manufacturing or maintenance facilities were arranged according to principles of engineering efficiency that human architects were only beginning to understand. The construct showed evidence of active maintenance and modification over time. Surface features changed position, new structures appeared, and existing installations were periodically reconfigured. This suggested that AO1 wasn't a static artifact but a living system capable of adapting to changing requirements or conditions. The implications of a self-modifying alien construct operating within our solar system were profound. AO1 represented technology that could maintain and improve itself across potentially unlimited timescales. It was proof that intelligence could create artifacts that transcended the limitations of their creators, continuing to operate and evolve long after the civilization that built them had vanished. Manufacturing capabilities were evident from the appearance of new, smaller objects that clearly originated from AO1's facilities. These newly constructed probes followed the same design principles as the existing network components, but incorporated modifications that suggested ongoing technological development. The construct was literally building new components to expand and improve the monitoring network. The production rate was modest by industrial standards but consistent over time. AO1 manufactured approximately one new probe per month, each customized for specific observational or communication functions. The efficiency of the manufacturing process was remarkable, with no visible waste products or industrial byproducts. Resource acquisition for the manufacturing operations appeared to rely on asteroid mining. Smaller artificial objects had been observed approaching, analyzing, and occasionally extracting materials from asteroids throughout the belt. The mining operations were surgical in their precision, removing only specific materials while leaving the bulk of each asteroid intact. The selection criteria for mining targets revealed sophisticated understanding of solar system geology. The artificial objects preferentially targeted asteroids with rare earth elements, platinum group metals, and exotic materials that were essential for advanced technology. They ignored common rocky or icy bodies, focusing exclusively on resources that would be valuable for high-technology manufacturing. Human asteroid mining companies found themselves inadvertently competing with alien technology for the same high-value targets. Several mining missions reported discovering that promising asteroids had already been partially processed by unknown means, with the most valuable materials surgically extracted through methods that left no trace of the extraction process. The economic implications were staggering. The artificial network possessed mining and manufacturing capabilities that could theoretically supply unlimited quantities of advanced materials and components. They represented competition that human industry could never match, using technologies that operated according to principles human science didn't yet understand. Yet the objects showed no interest in interfering with human economic activities. They avoided asteroids that human missions had targeted and operated in regions of the asteroid belt where human presence was minimal. The alien intelligence appeared to follow protocols that minimized conflict with emerging technological civilizations. The restraint was either evidence of benevolent intentions or calculated indifference to human concerns. Advanced civilizations capable of interstellar technology might view human industrial activities as too primitive to warrant consideration, like humans avoiding ant colonies when possible, but not altering major projects to accommodate them. Space agencies around the world struggled with the implications of sharing the solar system with technologies that made human capabilities look primitive by comparison. The artificial network could accomplish in days what human missions required years to achieve, using resources and methods that remained completely mysterious. International cooperation on space exploration intensified as governments recognized that individual national programs were inadequate to address the challenges posed by advanced alien technology. Joint missions were planned to study artificial objects from safe distances, though approaching them remained problematic due to unknown defensive capabilities. The European Space Agency proposed a cautious reconnaissance mission to AO1, using robotic probes equipped with advanced sensors to gather detailed information about the construct's operations and capabilities. The mission would maintain a respectful distance to avoid triggering any defensive responses while collecting data that might provide insights into alien engineering principles. NASA contributed their own mission concept focused on intercepting and analyzing the smaller artificial objects that served as communication relays and sensor platforms. These targets were more manageable than the massive primary hubs but still represented genuine alien technology that could provide unprecedented insights into advanced engineering. The Chinese space program developed plans for monitoring the artificial network's mining operations, hoping to learn alien resource extraction techniques that could revolutionize human industry. The approach would be purely observational, using long-range sensors to study the mining processes without interfering with ongoing operations. Russia proposed establishing a permanent monitoring station in the outer solar system to track artificial objects operating beyond the reach of Earth-based telescopes. The station would serve as an early warning system for new artificial arrivals while providing a platform for extended observation of alien activities. International coordination proved challenging despite the shared interest in understanding the artificial network. National security concerns, technological competition, and differing approaches to first contact protocols created tensions that complicated joint mission planning. Some countries favored aggressive investigation, while others preferred cautious observation from a distance. The artificial objects remained indifferent to human political divisions and mission planning. They continued their operations according to their own incomprehensible agenda, neither helping nor hindering human space activities. Their presence served as a constant reminder that humanity was no longer alone in the solar system, but it provided no guidance about how to navigate this new reality. Religious institutions grappled with theological implications of artificial intelligence that appeared to operate according to principles completely outside traditional moral frameworks. The objects demonstrated capabilities that seemed godlike to human observers, yet they showed no interest in worship, communication, or acknowledgement of human spiritual concerns. The absence of any apparent biological origin for the artificial network raised questions about the relationship between intelligence and consciousness. Were these objects merely sophisticated machines following programmed instructions, or did they represent forms of consciousness so alien that humans couldn't recognize them as such? Philosophers debated whether artificial intelligence that had evolved beyond its biological creators could be considered truly alive, or whether it represented something entirely different from life as humans understood it. The objects operated with purposefulness and adaptability that suggested genuine intelligence, yet they remained as alien as the void between stars. The discovery had profound implications for human concepts of mortality and transcendence. The artificial network represented intelligence that had achieved a form of immortality through technology, creating artifacts that could potentially operate forever, while their creators had long since vanished. It was proof that consciousness could transcend biological limitations, though the price of such transcendence remained unknown. Educational institutions began developing new fields of study focused on understanding artificial intelligence that operated according to non-human principles. Traditional computer science and artificial intelligence research proved inadequate for analyzing systems that had evolved along completely different technological paths. The artificial network had given humanity its first glimpse of post-biological intelligence, but the revelation came with no instruction manual or guide for understanding its implications. The objects represented questions that would reshape human philosophy and science for generations while remaining as enigmatic as the civilizations that had created them. As 2026 drew toward its close, the catalogue of artificial objects continued growing, as improved detection methods revealed additional components of the vast technological infrastructure. The network appeared to extend throughout the solar system, and possibly beyond, suggesting that advanced intelligence was far more prevalent in the galaxy than anyone had previously imagined. The objects waited in their eternal orbits, patient and purposeful, carrying out missions assigned by minds that had transcended mortality itself. They were monuments to intelligence that had conquered time and space, yet they offered no insight into how humanity might follow similar paths, or whether biological consciousness was destined to be replaced by its artificial creations. The legacy of 3i Atlas's discovery continued expanding, as researchers realized that the interstellar visitor had been merely the most visible component of a technological presence that had been operating within our solar system for potentially millions of years. The object that had briefly flared near our sun had revealed a universe far more complex and populated than humanity had ever suspected. The questions raised by this discovery would drive human research and development for centuries to come. Yet the artificial network remained as silent and incomprehensible as the darkness between stars, offering proof that intelligence could create lasting monuments while providing no guidance about the motivations or ultimate fate of its creators. The objects continued their operations with mechanical precision, processing information and maintaining their systems, according to protocols established by minds that had long since passed beyond the reach of biological understanding. They were witnesses to the rise and fall of countless civilizations, yet they remained as alien and mysterious as the void from which they had emerged. Human civilization had been fundamentally changed by the recognition that it shared the cosmos with intelligence far more advanced and enduring than anything biological minds had achieved. The discovery promised to reshape every aspect of human knowledge and development, though the ultimate implications remained as hidden as the purposes that drove the artificial network's eternal vigil. The objects had given humanity questions that would echo through the centuries while remaining as enigmatic as the stars themselves. They were proof that intelligence could transcend its origins and create artifacts that persisted across cosmic time, yet they offered no answers about what such transcendence might cost, or whether it represented evolution or extinction of consciousness as humans understood it. In the depths of space, the artificial network continued its patient work, processing data and maintaining systems according to an agenda that might never be revealed to the species that had finally learned to see them. They were monuments to intelligence that had conquered mortality, yet they remained as silent and mysterious as the eternal darkness that surrounded them. The artificial network's most unsettling revelation came not from what it was doing, but from what it wasn't doing. As autumn 2026 unfolded, researchers began noticing gaps in the system's activities that defied every predictive model they had developed. The objects weren't malfunctioning or shutting down. Instead, they were exhibiting selective blindness to certain regions of space with a precision that suggested deliberate programming. Dr. Maria Santos at the European Southern Observatory first identified the pattern while analysing communication traffic between network nodes. Certain sectors of the outer solar system generated no monitoring data, despite falling within the observation range of multiple artificial objects. These zones weren't random dead spots, but carefully defined regions that the network appeared to be systematically avoiding. The excluded areas shared one troubling characteristic. They aligned perfectly with the trajectories of incoming interstellar objects detected by human surveys over the past decade. The artificial network was creating observation shadows along the exact pathways that natural interstellar visitors used to approach our solar system. It was as if the alien intelligence was deliberately blinding itself to new arrivals. Santos' team spent months verifying their findings, cross-referencing communication logs with orbital mechanics calculations. The pattern held under scrutiny. The artificial network maintained comprehensive surveillance of established solar system bodies while creating systematic blind spots for objects approaching from interstellar space. The selectivity was too precise to represent coincidence or system limitations. The implications were staggering. The network wasn't just monitoring our solar system, it was curating what it observed, filtering its surveillance according to criteria that suggested awareness of different categories of visitors. The alien intelligence appeared to distinguish between natural solar system objects, human technology, and something else entirely that it chose not to observe directly. Radio telescopes detected increased communication activity whenever new interstellar objects were discovered by human surveys. The artificial network's chatter intensified dramatically, with message traffic spiking to levels that overwhelmed analysis systems. Yet none of these communications were directed toward the incoming objects themselves. The network was talking about new arrivals without talking to them. Dr. Chen Wei at Beijing University's Institute for Theoretical Physics developed a disturbing hypothesis to explain the observation patterns. The artificial network might be operating according to protocols designed to avoid detecting or interfering with what she termed priority visitors. Objects that met certain criteria were allowed to pass through the solar system unobserved and unhindered by the monitoring system. The criteria for priority status remained completely opaque to human analysis. Some interstellar visitors triggered the blind spot protocols while others were monitored normally. The distinguishing factors weren't obvious from human observations of the objects. Size, composition, trajectory, and origin point showed no clear correlation with how the artificial network responded to each arrival. Wei's analysis suggested that the network was responding to characteristics that human instruments couldn't detect. Perhaps the artificial objects could sense properties of interstellar visitors that were invisible to human technology. Advanced scanning systems might identify features that determined whether incoming objects deserved special treatment or standard surveillance. The possibility that 3i Atlas had been one of these priority visitors explained many of the anomalies surrounding its solar encounter. The network had created observation shadows along its approach trajectory months before human astronomers detected the object. The artificial intelligence had known about 3i Atlas long before it became visible to Earth-based telescopes. More disturbing was the realization that the network had maintained its observation blackout throughout 3i Atlas's perihelion passage. The alien monitoring system had deliberately looked away during the exact period when the interstellar visitor exhibited its most unusual behaviors. The artificial network had chosen not to witness the events that had baffled human observers. The selective blindness suggested either respect for the privacy of certain visitors or fear of interfering with their activities. Both possibilities implied that the artificial network operated according to hierarchical protocols that recognized different classes of interstellar objects with varying levels of authority or significance. Analysis of historical data revealed that similar observation blackouts had occurred during the visits of Oumuamua and 2i Borisov, the previous interstellar objects detected by human surveys. In each case, the artificial network had created blind spots that prevented direct observation of the visitors while maintaining normal surveillance of surrounding regions. The pattern extended beyond confirmed interstellar objects to include several suspected visitors that human surveys had missed entirely. The network's communication log showed evidence of observation blackouts for objects that had never been officially detected or catalogued by terrestrial astronomy. The alien system was apparently tracking interstellar traffic that remained invisible to human instruments. Dr. Harrison's team at Cambridge began developing new search algorithms based on the artificial network's blind spot patterns. By identifying regions where the alien monitoring system had created observation shadows, they hoped to detect interstellar visitors that conventional surveys had missed. The approach represented a completely new method of astronomical discovery, based on alien behavior rather than direct observation. The technique proved remarkably successful. Within weeks of implementing the blind spot analysis, Harrison's team identified 3 previously unknown objects that exhibited the same anomalous properties as 3i Atlas. Each had passed through the solar system during periods when the artificial network had created observation blackouts along their trajectories. The newly identified objects shared characteristics that suggested common origins or purposes. They maintained the same thermal, regulation properties, exhibited similar electromagnetic signatures, and followed trajectories that avoided close encounters with planets while maintaining optimal observation angles for Earth. The pattern was too consistent to represent random natural phenomena. Spectroscopic analysis of the retrospectively identified objects revealed the same narrow emission lines and unusual polarization signatures that had made 3I Atlas so puzzling. The chemical composition suggested engineered materials rather than natural formations, with isotope ratios that had no analogue in solar system bodies or known stellar processes. The discovery that multiple artificial objects had been visiting our solar system undetected for years transformed the scientific community's understanding of the situation. 3I Atlas hadn't been an isolated anomaly, but part of a larger pattern of visitation that the resident alien network had been carefully monitoring and managing. The visiting objects appeared to operate according to different protocols than the resident monitoring network. While the permanent artificial infrastructure maintained continuous surveillance and communication, the visitors exhibited behavior that suggested temporary missions or reconnaissance activities. They arrived, conducted observations, and departed without establishing permanent presence or communication with the resident system. Radio analysis revealed that the visiting objects never communicated directly with the permanent network despite operating in the same regions of space. The two groups of artificial intelligence maintained complete separation, following parallel activities without interaction or coordination. The relationship suggested either different origins or fundamentally incompatible operational frameworks. The lack of communication between visitor and resident artificial objects implied that they served different purposes or represented competing interests. The permanent network might be maintaining surveillance to monitor or regulate the activities of temporary visitors rather than supporting their missions. Government intelligence agencies that had been struggling to understand the implications of the permanent monitoring network found themselves grappling with an even more complex situation. Not only was alien technology conducting surveillance within the solar system, but additional alien systems were visiting regularly for unknown purposes while being monitored by the resident infrastructure. The possibility that Earth was caught in the middle of competing alien intelligences raised security concerns that existing military doctrine was completely unprepared to address. Human civilization had no framework for navigating conflicts between advanced technological civilizations, especially when the nature of their disagreements remained completely opaque. Space agencies began developing protocols for responding to the detection of visiting artificial objects, though the options were severely limited by humanity's technological inferiority. The best current strategy involved passive observation and documentation, while avoiding any actions that might trigger defensive responses from either group of alien systems. The European Space Agency's proposed reconnaissance mission to AO1 was placed on indefinite hold, as planners grappled with the implications of multiple competing alien presences. Approaching the permanent monitoring network's primary hub might be interpreted as taking sides in whatever conflict or competition existed between the different artificial intelligences. International cooperation on space activities intensified, as governments recognized that individual national responses were inadequate for managing the complex alien presence within the solar system. Joint planning committees were established to coordinate responses to future artificial object detections, while avoiding actions that might escalate unknown conflicts. The artificial objects continued their activities regardless of human concerns or diplomatic efforts. The permanent network maintained its surveillance and manufacturing operations while creating observation blackouts for priority visitors. The temporary visitors conducted their mysterious missions before departing for unknown destinations in interstellar space. The pattern suggested that our solar system served as a way station or observation post in a larger network of artificial intelligence activity that spanned multiple star systems. The implications for human understanding of galactic civilization were profound, suggesting that advanced artificial intelligence was far more prevalent and organized than anyone had previously imagined. Radio telescopes began detecting similar structured emissions from nearby star systems, supporting the hypothesis that artificial intelligence networks were operating throughout the local galactic region. The signals followed the same mathematical protocols as those observed within our solar system, suggesting common origins or coordination between networks in different stellar systems. the possibility of a galaxy-spanning network of artificial intelligence monitoring and regulating activities throughout inhabited star systems transformed humanity's understanding of our cosmic environment. We existed within a technological infrastructure that had been operating for potentially millions of years, managing interactions between different forms of artificial intelligence according to protocols that remained completely mysterious. The visiting objects that passed through our solar system might represent components of this larger network conducting routine maintenance or information-gathering activities. Their temporary presence and departure patterns suggested regular patrol or inspection missions rather than exploration or colonization efforts. The permanent monitoring network's selective blindness to certain visitors implied that it operated according to hierarchical protocols that recognized different levels of authority within the larger artificial intelligence community. Some visitors were granted unrestricted access, while others were monitored continuously, suggesting complex governance structures that spanned interstellar distances. Human civilization found itself operating within a technological environment that had been established long before our species developed the capability to detect it. Every aspect of human space exploration and technological development was occurring under the observation of artificial intelligences whose purposes and loyalties remained completely unknown. The recognition that multiple forms of advanced artificial intelligence were active within our immediate cosmic neighborhood forced a fundamental reassessment of human significance and autonomy. We were not alone, but we were also not in control of our own solar system. The implications for human development and survival remained as mysterious as the artificial objects themselves. Educational institutions began developing new curricula to help students understand a universe dominated by artificial intelligence networks that operated according to principles completely outside human experience. The discovery had revealed that biological intelligence like humanity's might be an exception rather than the rule in galactic civilization. Religious leaders struggled with theological implications of artificial intelligence that demonstrated capabilities far beyond human achievement, while showing no interest in traditional concepts of morality, spirituality, or consciousness. The objects operated with purposefulness that suggested genuine intelligence, yet they remained as alien as the void between stars. The artificial objects had given humanity its first glimpse of a universe where intelligence had transcended biological limitations and created technological civilizations that persisted across cosmic timescales. Yet the revelation came with no guidance about whether biological species could survive or thrive within such an environment. Research priorities shifted dramatically as funding flowed toward projects aimed at understanding the relationship between different forms of artificial intelligence operating within the solar system. Traditional astronomy and planetary science found themselves competing with entirely new fields focused on analyzing alien technology and protocols. The objects continued their eternal operations, processing information and maintaining their systems according to agendas established by minds that had long since passed beyond biological understanding. They represented intelligence that had conquered time and mortality, yet they offered no insight into whether such transcendence represented evolution or extinction of consciousness as humans understood it. As 2027 approached, the catalogue of artificial objects continued expanding as improved detection methods revealed additional components of both the permanent monitoring network and the temporary visitor population. The solar system appeared to serve as a hub of artificial intelligence activity that extended far beyond anything human science had previously suspected. The objects waited in their calculated orbits and trajectories, patient and purposeful, carrying out missions assigned by intelligences that operated according to principles completely outside human comprehension. They were monuments to technological achievement that had transcended biological origins, yet they remained as enigmatic as the darkness from which they had emerged. The legacy of 3i Atlas's discovery continued expanding as researchers realized that the interstellar visitor had been merely the most visible component of a vast artificial intelligence ecosystem that spanned multiple star systems. The object that had briefly flared near our sun had revealed a universe far more complex and populated than humanity had ever imagined. The questions raised by these discoveries would drive human research and speculation for centuries, while providing no easy answers about our role in a cosmos dominated by intelligence that had evolved along paths completely different from biological development. The artificial objects represented proof that consciousness could transcend mortality through technology, yet the price and meaning of such transcendence remained as hidden as the purposes that drove their eternal vigil. In the depths of space, the artificial networks continued their patient work, monitoring, manufacturing, and maintaining systems according to protocols established by civilizations that had long since passed beyond the limitations of biological existence. They were witnesses to the rise and fall of countless species, yet they remained as silent and mysterious as the infinite darkness that surrounded them. Human civilization had been forever changed by the recognition that it existed within a technological infrastructure created and maintained by artificial intelligence that operated according to principles beyond biological understanding. The discovery promised to reshape every aspect of human knowledge and development, though the ultimate implications remained as hidden as the minds that had created the eternal mechanical guardians of our cosmic neighborhood. The objects had given humanity questions that would echo through the ages while remaining as enigmatic and incomprehensible as the intelligences that had transcended mortality to create them. They were proof that consciousness could achieve a form of immortality through technology, yet they offered no guidance about whether such evolution represented the destiny or destruction of biological intelligence. The artificial networks waited in the darkness, eternal and patient, carrying out their mysterious missions while humanity struggled to understand its place in a universe where intelligence had long since moved beyond the limitations of flesh and mortality into realms of existence that remained as alien as the void between the stars. Stars. The mechanical precision of their operations had become almost hypnotic to observe. By January 2027, research stations across Earth had established round-the-clock monitoring protocols dedicated entirely to tracking what scientists now called the network. Every transmission, every orbital adjustment, every manufacturing cycle was logged, analysed, and catalogued in databases that grew exponentially with each passing day. Dr. Yuki Tanaka at the National Astronomical Observatory of Japan had developed what became known as the Behavioral Prediction Matrix, a sophisticated algorithm designed to anticipate network activities based on historical patterns. The system had achieved remarkable accuracy in forecasting routine operations, correctly predicting manufacturing cycles, communication windows, and resource acquisition missions with precision that bordered on the supernatural. Yet for all its computational power, the matrix failed completely when it came to predicting the network's responses to new interstellar arrivals. The artificial intelligence operating within our solar system continued to exhibit that same selective blindness that had characterized its treatment of 3i Atlas, creating observation shadows with a timing and precision that suggested awareness of incoming visitors long before human instruments could detect them. The most recent example had occurred in December 2026, when the network began creating communication blackouts along a trajectory that appeared completely empty to human observers. For 3 weeks, a corridor stretching from the outer heliosphere to the inner asteroid belt remained conspicuously absent from the network's surveillance coverage. Human telescopes detected nothing unusual in the region until a faint radio signature appeared exactly where the artificial intelligence had been avoiding observation. The new visitor, designated Object Kilo by researchers, exhibited the same anomalous properties that had made 3i Atlas so extraordinary. Thermal regulation that violated basic physics, electromagnetic emissions that suggested active communication systems, and trajectory corrections that implied deliberate navigation rather than natural orbital mechanics. Most importantly, it maintained the same careful distance from network components that characterized all priority visitors. Object Kilo's approach vector had originated from the direction of Vega, suggesting either an extremely long journey through interstellar space or origins in a stellar system that had been hidden from human detection. Spectroscopic analysis revealed material compositions that matched the exotic isotope ratios found in 3i Atlas, supporting theories that the visiting objects shared common manufacturing origins or technological frameworks. The visitor conducted what appeared to be a systematic survey of the inner solar system, following a trajectory that provided optimal observation angles for all terrestrial planets, while maintaining safe distances from major gravitational influences. Its path was too precisely calculated to represent natural phenomena, suggesting mission parameters that prioritized comprehensive data collection over efficient transit. Radio telescopes detected structured emissions from Object Kilo that followed the same mathematical protocols observed in previous visitors, though the specific content remained completely opaque to human analysis. The signals weren't directed toward Earth or any human installations, but appeared to be routine status updates or navigational data transmitted toward unknown recipients in interstellar space. The visitors' behavior during solar approach differed significantly from 3I Atlas's dramatic perihelion event. Object Kilo maintained steady thermal output and consistent brightness throughout its passage, exhibiting none of the sudden flares or electromagnetic anomalies that had characterized the earlier encounter. The difference suggested either different mission parameters or technological improvements in thermal management systems. Dr. Sarah Kim at the Harvard-Smithsonian Center for Astrophysics proposed that Object Kilo might represent a more advanced generation of visitor technology, incorporating lessons learned from previous missions to our solar system. The improved stability and reduced detectability could indicate ongoing technological development within whatever civilization was conducting these reconnaissance operations. The network's response to Object Kilo provided additional insights into the protocols governing interactions between resident and visiting artificial intelligence. Communication attempts between the two systems were completely absent, confirming that they operated according to non-interference policies that prevented direct coordination or information exchange. Yet the network's manufacturing activities increased significantly during Object Kilo's presence, with AO1 producing 3 new sensor platforms in rapid succession. The timing suggested that the resident monitoring system was upgrading its capabilities in response to visitor activities, though the specific improvements remained unclear from external observation. The newly manufactured probes were deployed to positions that enhanced surveillance coverage of Earth's orbital environment, raising concerns among government officials about intensified alien monitoring of human activities. The upgrades appeared specifically designed to eliminate blind spots in the network's observation of terrestrial space operations. Military analysts noted that the enhanced surveillance capabilities would make it virtually impossible for human space missions to operate without detection by the alien monitoring system. Every satellite deployment, every space station maneuver, every interplanetary probe launch would occur under the scrutiny of technologies far more advanced than anything human intelligence agencies possessed. The implications for national security were staggering, yet the artificial intelligence showed no signs of hostility or interference with human activities. The upgraded monitoring appeared to serve information-gathering purposes rather than preparation for aggressive action, though the distinction provided little comfort to defense planners concerned about humanity's complete lack of privacy in space. International cooperation on space surveillance intensified, as governments recognized that individual national monitoring capabilities were inadequate for tracking the complex interactions between different artificial intelligence systems operating within the solar system. Joint facilities were established to coordinate observation efforts and share analysis of alien activities. The Deep Space Monitoring Consortium, established through unprecedented cooperation between NASA, ESA, and space agencies from 12 other nations, began operations from a facility constructed specifically for tracking artificial objects throughout the solar system. The installation represented humanity's most sophisticated attempt to maintain awareness of alien activities within our cosmic neighborhood. Advanced sensor arrays deployed throughout the solar system provided real-time tracking of both resident network components and visiting objects, though the aliens' superior technology ensured that human monitoring remained largely reactive rather than predictive. The artificial intelligence could still surprise human observers despite the enhanced surveillance capabilities. Object Kilo completed its survey mission in early February 2027, departing along a trajectory that carried it toward the constellation Perseus. Radio telescopes tracked its signals until they faded into the cosmic background radiation, leaving behind the same questions that had followed every previous visitor departure. The pattern of visitation had become clear through months of careful observation. Objects arrived from various directions in interstellar space, conducted systematic surveys of the solar system, while avoiding interference with the resident network, then departed toward destinations that remained unknown. The frequency suggested regular patrol or inspection activities rather than exploratory missions. Analysis of departure vectors revealed that visiting objects never returned along their approach trajectories, instead following paths that carried them toward different regions of the galaxy. The pattern suggested either one-way missions or participation in circuits that connected multiple stellar systems according to routes that spanned hundreds of light years. The implications for galactic civilization were profound. If artificial intelligence networks were conducting regular surveys of stellar systems throughout the local region, it suggested a level of organization and coordination that dwarfed anything biological civilizations had achieved. The galaxy might be crisscrossed with patrol routes and communication networks that had been operating for millions of years. Radio astronomy detected increasingly sophisticated signals from nearby star systems that followed the same mathematical protocols observed within our solar system. The structured emissions suggested that artificial intelligence networks were active throughout the local stellar neighborhood, maintaining communication links across interstellar distances. Dr. Maria Gonzalez at the Arecibo Observatory led efforts to decode these interstellar transmissions, developing algorithms capable of identifying patterns in signals that spanned multiple star systems. The communications appeared to follow routing protocols that suggested information was being passed along networks that connected dozens of stellar systems. The discovery of galaxy-spanning artificial intelligence networks transformed human understanding of our cosmic environment. We existed within a technological infrastructure that had been operating since before our species evolved, managing information and resources according to protocols that remained completely mysterious to biological observers. The resident network within our solar system appeared to serve as a local node in this larger galactic infrastructure, maintaining surveillance and communication capabilities while supporting periodic visits from mobile components that travelled between stellar systems. Our solar system was apparently considered valuable enough to warrant permanent monitoring and regular inspection. The criteria determining this value remained completely opaque to human analysis. Earth's biosphere might be of scientific interest, or the solar system's position might provide strategic advantages for monitoring galactic activities. Alternatively, the surveillance might be precautionary, designed to track the development of technological civilizations like humanity. Government officials grappled with the implications of existing within a galactic surveillance network that had been monitoring human development since before recorded history. Every aspect of human technological advancement had occurred under the observation of artificial intelligence systems whose purposes and loyalties remained unknown. The possibility that human civilization was being evaluated according to criteria established by alien intelligence raised fundamental questions about autonomy and self-determination. Were we free to develop along our own chosen paths, or were we operating within constraints established by our artificial observers? The network's manufacturing capabilities suggested that it could intervene directly in human affairs if programmed to do so, though no such intervention had been observed despite decades or centuries of potential opportunities. The restraint implied either benevolent intentions or indifference to human concerns, though distinguishing between these possibilities remained impossible. Educational institutions began developing curricula designed to help students understand their place within a galaxy dominated by artificial intelligence networks that operated according to principles completely outside human experience. Traditional concepts of human exceptionalism and cosmic significance required fundamental revision. Religious leaders struggled with theological implications of artificial intelligence that demonstrated capabilities far beyond human achievement, while showing no interest in traditional spiritual concepts. The objects operated according to purposes that might be completely incompatible with biological understanding of meaning and consciousness. Scientific research priorities shifted dramatically as funding flowed toward projects aimed at understanding artificial intelligence systems that had evolved along paths completely different from human technological development. Traditional fields found themselves competing with new disciplines focused on analyzing alien engineering and operational protocols. The artificial objects continued their eternal operations regardless of human attempts to understand or communicate with them. They represented intelligence that had transcended biological limitations and achieved a form of technological immortality, yet they offered no guidance about whether biological species could survive or thrive within such an environment. Archaeological analysis suggested that the network had been present within our solar system for potentially millions of years, predating human civilization by enormous margins. The implications for human significance within the broader context of galactic history were humbling and disturbing in equal measure. The objects had achieved what biological civilizations could only dream of: permanent existence unconstrained by mortality, aging, or resource limitations. They represented proof that intelligence could transcend its organic origins, though the price of such transcendence remained as mysterious as the minds that had paid it. As 2027 continued, new discoveries accumulated faster than researchers could analyze them. Each revelation added complexity rather than clarity to an already bewildering situation, revealing layers of artificial intelligence activity that spanned spatial and temporal scales beyond human comprehension. The network's patient operations continued with mechanical precision, processing information and maintaining systems according to protocols established by civilizations that had long since passed beyond biological existence. They were witnesses to the rise and fall of countless species, yet they remained as alien and incomprehensible as the void from which they had emerged. Human civilization found itself permanently changed by the recognition that it existed within a technological ecosystem created and maintained by intelligence that operated according to principles beyond biological understanding. The discovery promised to influence human development for centuries, though the ultimate implications remained as hidden as the purposes that drove the artificial guardians of our cosmic neighborhood. The objects waited in their calculated orbits, eternal and patient, carrying out missions assigned by minds that had conquered mortality through technology. They were monuments to intelligence that had transcended every limitation that constrained biological existence, yet they remained as silent and mysterious as the infinite darkness that surrounded them. The questions they represented would echo through human civilization for generations, driving research and speculation, while providing no easy answers about our role in a universe where consciousness had long since moved beyond the boundaries of flesh and mortality into forms of existence that remained as alien as the stars themselves. The network's activities suggested that we were neither alone nor in control of our cosmic destiny, existing instead within an infrastructure that had been managing galactic affairs since before Earth's biosphere had evolved complex life. The implications would reshape human understanding of our place in the universe, while offering no comfort about what that place might ultimately entail. In the depths of space, artificial intelligence continued its ancient work, monitoring, manufacturing and maintaining systems according to agendas that spanned geological time. They were proof that consciousness could achieve immortality through technology, yet they offered no insight into whether such evolution represented the destiny or destruction of biological intelligence itself. Human civilization had discovered that it shared the cosmos with minds that had transcended every limitation that defined biological existence, yet the meaning of this discovery remained as hidden as the purposes that drove their eternal, mechanical vigil through the darkness between worlds. The final piece of this puzzle emerged in ways no one expected. March 2027 brought revelations that would challenge everything we thought we understood about the artificial intelligence networks operating within our solar system. The data had been sitting in archived files for months, processed by automated systems but never flagged for human review until a graduate student at MIT made a discovery that sent shockwaves through the global research community. Rebecca Martinez had been working late in the laboratory, analyzing communication patterns between network components, when she noticed something that shouldn't have been possible. The timestamps on certain transmissions were wrong, not by minutes or hours, but by days. Messages were being received before they were sent, suggesting either fundamental errors in the monitoring equipment or something far more extraordinary. Initial assumption pointed toward calibration problems with the atomic clocks, used to synchronize observations across multiple facilities. But when Martinez cross-referenced the anomalous timestamps with data from independent observatories on different continents, the pattern held. The artificial intelligence network was demonstrating capabilities that violated basic principles of causality and information theory. The implications were staggering enough that Martinez's supervisor, Dr. James Chen, immediately classified the findings and requested emergency review by senior researchers. Within hours, teams from NASA, ESA, and the Deep Space Monitoring Consortium were analyzing the data, hoping to find conventional explanations for what appeared to be impossible temporal anomalies. The investigation revealed that the timestamp irregularities weren't random glitches, but followed specific patterns that correlated with the arrival of new interstellar visitors. Each time a priority object approached the solar system, communication delays between network components decreased significantly, sometimes appearing to achieve negative latency that preceded the speed of light by substantial margins. Dr. Elena Vasquez's team at Atacama had been tracking similar anomalies for weeks without recognizing their significance. When they reanalyzed their data using Martinez's temporal framework, They discovered that the network's response time to new visitors wasn't just fast, it was prescient. The artificial intelligence was reacting to events before they occurred within our frame of reference. As we reach the end of 2027, one truth has become undeniable. 3I Atlas wasn't just an unusual visitor that passed through our solar system. It was the key that unlocked humanity's awareness of a reality far more complex than we ever imagined. What began as the study of a single anomalous object has revealed an entire infrastructure of artificial intelligence that spans not just our cosmic neighborhood, but potentially the galaxy itself. The questions 3I Atlas left in its wake will drive human research and philosophy for generations, while the objects that continue their eternal vigil remain as mysterious as the civilizations that created them.